Okay, welcome. We are now ready to use our lapply function with what we know about bootstrap confidence intervals to construct a function for constructing a bootstrap confidence interval that uses apply functions instead of for loops, which was how we first implemented this in the previous module. So we've talked about how we can create bootstrap resamples and how we can calculate the mean of those samples using an lapply function. So that's what this code is doing over here. It's creating a list called bootstats that is where we're storing the mean from each of our bootstrap resamples. So what's left to do after we create this list, bootstats, is to use it to find the cutoffs for the confidence interval. And so just recall how that works again for a 95% confidence interval, and we can adjust those values for other confidence levels. So what we would need to do with this output from bootstats is we want to unlist it, right? We want to calculate the quantile of all of these values, which the quantile function takes a vector as an input, not a list. So we're gonna use the unlist function. That's going to convert the list of sample means into a numeric vector. Then we're going to calculate this value alpha, which corresponds to how much area is not in the middle. And then we'll use that value of alpha to find the cutoffs for our confidence interval using quantile function. So what we've got is a vector of data, our original sample, which we stored in a vector called WT in a previous code cell. In this case, I'll think about what would a 95% confidence level be. So my confidence level, I'm going to enter as a decimal, as a quantile, or excuse me, as a decimal 0.95. And then we're going to specify how many bootstrap resamples do we want to generate in our bootstrap distribution. And we're going to pick B to be 10,000 by default. So I'm going to run this code cell just so we have those inputs. And I'm going to clear my drawing out of the way as well. Okay, so now that we've got those inputs, we can now just add these additional commands, the unlist, and find the quantiles after we've gone through this lapply function to calculate and store bootstrap statistics. So we do all of this stuff over here. We've got everything stored in bootstats, which is a list. But now I want to convert that list to a numeric vector. So that's what this command is doing, the unlist function. I'm going to calculate this value of alpha. And in fact, I could save a little bit of memory. I don't necessarily need to store that value. And then we're going to go ahead and calculate the upper and lower cutoffs using the quantile function. So we're going to go into what is now a vector, a numeric vector, bootstats, and we're going to calculate both quantiles at the same time. I've entered both of those probabilities as a vector in the prob argument. So I'm going to run this. I set the seed, so I'm going to get consistent output here. I set the seed to 43. And in the output, we can see that the lower cutoff is 243.11 grams. The upper cutoff is 278.76 grams. So this is giving us a range of plausible values for the mean weight of all 6-week-old chicks. So let's just take this previous code and we're going to create a function from it. So the function is going to be called bootstrap CI underscore CI for bootstrap confidence interval. It's a function. We're going to take 3 inputs in this function. We need a vector of data. So this is a numeric vector. This is like our original sample. We specify a confidence level, and the default if no confidence level is specified, is going to be a 95% confidence interval. And then we specify how many bootstrap resamples we want to include. And if B is not specified, then the default is going to be 10,000. So it's going to take three inputs, a sample, maybe a confidence level, and maybe a value for B if we want to customize those. And those are going to be input into this loop that we just had before, or into this function that we just had before. So it's going to go in and calculate bootstrap statistics using lapply. Those are now stored in a list. We convert that list to a vector, and then we calculate the cutoffs using the quantile function. And this is going to create that function. And here we're going to run it using the same seed, and we can check that we are getting the same output from when we ran it the first time above. Just with this command over here, we could more easily customize the confidence level. If I had another sample, I could just reuse this code with a different sample rather than have to change the lapply function. So there's our 95% confidence interval. And again, what this is telling us is there's a 95% chance that this interval from 243.11 grams up to 278.76 grams contains the actual mean weight of all chicks at 6 weeks. And we don't know whether that mean is in the actual mean is in this interval or not, but we do know that the odds that it is inside of this interval, there's about a 95% chance that this interval captures that value. Okay, so we'll go through another method for constructing bootstrap confidence intervals using a loop. This is what we did in the previous module. And then what I want to do is compare the computational speeds of the loop compared to the lapply method that we just talked about in this video.